Hi, Roman.
All right. I'll share slides. Yep, looks like maybe we won't get any people outside the group this time either.
I would expect that we're never going to again, except for maybe our last one.
So, yeah, we get to start the slides.
Yeah. So unpacking.
Are we still keeping the honorable tradition of having an interview?
Oh, right.
I was
Thanks
planning to
for
slot
that.
right back into that.
Yeah, almost forgot.
Yeah, I was planning to just jump right back into that. And for the first thing, I was thinking about all three of these problems that you've listed, right? So the third problem listed here is unpacking observations.
Yep.
First
and
problem
then-
is how do we maintain propositional consistency for our logical inductor, which I think that we've even mostly resolved at this point, right? Or no?
the second problem is what are observations, and I just make a
Yeah.
strong claim about what the answer to that one is. The first problem was
How do we
the terrible
enforce,
prior.
yeah, propositional
Which-
consistencies?
I mean, the terrible prior problem has multiple aspects to it, right? Like
Okay.
propositional consistency. Yeah, I don't know. Like my
I mean, that's one way in which something can have a garbage prior. It can have a prior that's blatantly propositionally inconsistent and which is never going to become propositionally consistent.
right, yeah.
Uh,
But that's only one way to have a garbage prior. So kind of it's still an open question as per these slides, like what are all the things that we need to have a terrible prior, and what exactly does that mean? Of course, my suggestion is going to be that it means something like we can have a tiling theorem. I think there are other aspects of what it could mean to have a terrible prior, which I have a different talk on, but yeah.
okay.
Did you have more to
Right.
say on those three problems?
Not entirely. I was just sort of trying to provide some context here for starting off with third problem and poking at it a little bit and trying to figure out if there's any commonality to all these problems with UDT as described or logical inductors as described.
Right. So these problems are, of course, basically just the organizing narrative that I came up with for the talk. Like, here's three subjects that I wanted to talk about. So I'm not making some strong claim that these are the three problems. Possibly there would be like a better organizational structure for the content such that I could make a strong claim about what the core problems are, but
Right.
to the extent that there is a natural
Hello?
progression, the natural progression.
Yeah, okay. You froze up for a second there. That's all. I can hear.
Gotcha. So to the extent there is a logical progression, I would say that it is, well, our first concern is we have a terrible prior. What would we need to address that concern? And then I'm like, well, we would need to be able to reason about how updateless agents think in a way that gives us confidence that they will behave updatefully in cases where that's appropriate. But then how do we like decompose the nuts and bolts of that reasoning? We get constraints like propositional consistency that we might want. We have other ideas of constraints, but then what are these observations that we state these constraints in terms of? And then that's like problem 2, and then we talk about Bayesian logical induction, but then, and then Bayesian logical induction seems to entirely answer that question, what are the observations? But then backing off a little bit again, we're like, oh wait, we still didn't solve the whole problem. So we don't just want a notion of observation, we want to be able to do updateless decision theory.
Yeah.
And that's what this third problem is about like the remaining part of updateless decision theory.
Mhm. Okay.
And
I've
so
already good.
Yeah, like the culmination of the research with Martin Soto last year was this version of updateless decision theory, which is not a good version of updateless decision theory. This was kind of the avenue we went down because we could understand how to get it to work, but it's just, it doesn't, it's not able to do things like transparent Newcomb correctly. It's not able to do things like counterfactual mugging correctly, if I recall. It's just not a very good version of updateless decision theory.
Right.
Yeah.
Can I ask what this version actually means?
Yeah.
Like,
Okay.
the left-hand side doesn't depend on the observation. So what's that specific observation that got chosen for this argmax?
Yeah. So we can really, maybe I should still index the action by the observation. It's not like there's one global action we take. We can like A sub O. The so the meaning
Hello.
of this is like, if we have like, we're conditioning on the material implication, right? So we're representing policy points as material implications instead of as this equational thing. So what we're saying is that I'm able to make it impossible that I get this observation and don't take this action. So I'm cutting out that world, like, right? I'm cutting out all worlds where I see this particular observation and then take this particular action in response. And so what that does,
I didn't follow. So where does the cutting out worlds happen?
it's the Bayesian conditioning to take the expected value is what I'm asking you to imagine. I know this is in the form where we're not actually Bayesian conditioning, but basically like we're conditioning on this proposition. What does this proposition mean? It's just the material implication. It just means that we cannot have this observation and not have this action, right? So we're just conditioning on the proposition that it is not the case that big A equals little a and big O equals little o.
So is the idea like you imagine yourself to be some kind of program or like physical deterministic thing, so that you could have this kind of material implication? And not essential to.
Yeah, I think that's not essential to this. Like, a material implication is a weak sort of implication, right? It's just saying that it's not the case that you have the observation and not the action. So it's not saying that, like, this expression doesn't claim that the observation logically implies the action. So it's not like, you're some program such that you can like logically imply something. It's just like you can't have these two circumstances at once, namely that you have the observation and you don't have that action.
Norman, this is, I would put it differently maybe. This is we're conditioning here on the proposition that you don't see O or that you do see A. At least one of those things has to be true.
Yeah.
But okay, so I'm actually taking a logic course right now. So
Yes.
in the course, like, this is how the professor defined logical implication. What's the difference?
Yeah, there is a difference. So, for example, the material implication that if the moon is made of blue cheese, then I'm the president of the world is true, because the moon is not made of blue cheese. But me being president of the world does not logically follow from the moon being made of blue cheese, because you would need more axioms in order to establish that conclusion from that assumption. Like, these are just logically independent facts without any more axioms.
So is it like the difference between like the model, the proof perspective versus the model perspective?
Yeah, it's like material implication can be defined just from it's truth functional. It's just a factor of what's true, whereas like logical implication need a logic to like you. Yeah.
Okay.
Yeah,
I think Roman still has questions about this. So
yeah, material implication just is it's another term for the if commonly used in logic. Like, material implication just means that you either have the consequent or you don't have the antecedent.
It's the difference here between from P we can prove Q, and we can't actually rule out that P implies Q because we don't even have P.
Yeah. So
we don't is the thing. That's the point.
The reason why this is a terrible Roman, yeah. So the material implication is also distinct from conditioning, right? So if you're a logic-minded person, probably the first thing that you think of when you hear if then is material implication, and then the second thing that you would think of is like logical implication. So these are two interpretations of if then. But then if you're a probability-minded person, the first thing you think of when you hear if then is like conditioning on something. And that's just a third separate interpretation of if then.
It's separate. I don't know that it's separate.
I mean, of course there are connections, but if I'm interpreting somebody's if then as like a high conditional probability, that's entirely different from interpreting it from a material implication.
Yeah. Do we separate logic and material world?
I guess
Say more about that?
Yeah, I didn't answer that question when you asked it earlier because I just don't know what it means.
World is I think he's asking about the. I think Roman might be asking about the format of our observations, and in that case, my temptation is to say that no, we don't, because we have all the stuff about our observation being something born of logical uncertainty, and then also we have some observations that are born of epistemic uncertainty, and we
Yeah,
don't really draw much of a line between those.
yeah. The question is, do we have separate notation for talking about logical things versus material things? The answer should be no. The logic is just like the language in which we speak, and we might speak of material things, we might speak of mathematical things like 1 + 1 = 2, but it should be in the same logical language.
I think Roman is asking this question because of the word material that's being used in material implication. But I don't think that refers to material world. It's more like actual or de facto.
Yeah, material in material implication does not mean material world. I think it means something like, well, like given the facts on the table, like material implication is the truth functional notion of implication, and truth functional is, I don't know, it's an important condition in logic. So that's really what that word is saying. Okay, so this notion of UDT is really bad because the you're ruling out that you don't take that action. So you're ruling out all the other actions for that observation. This has two bad properties. One of the bad properties is it necessarily diminishes the probability of that branch, the probability of that observation, because you're just knocking out some probability mass from that observation by conditioning on that. And so that's kind of weird. That's not always sensible. And then the second problem is that because you're just knocking out some probability mass from that observation, you don't change the probabilities on what happens in any other branches. So that's why it doesn't do counterfactual mugging right, because omega, like if you're using this for form of updateless decision theory, then you're basically saying, well, omega can't look at other branches and see what happens. Like the fact that I give up the $10 just diminishes the probability of the branch where omega asked for $10 and doesn't have any impact on whether omega gives me the $100 in the other branch.
Okay, there's something I definitely don't get here, because I don't quite see why it is conditioning on something reduces probability.
So if I have first I randomly choose 3 baskets.
Okay.
The basket of red things, the basket of blue things, and the basket of green things. And then I randomly draw an object from that. And so I can get a triangle, I can get a giraffe, or I can get a bar of soap. All 3 of which have that color. And then so that's my probability distribution. Okay. Now I condition on I did not get a red bar of soap.
Yes.
Then the
and that makes ending up
through the red basket decreases.
Yes.
That's what's going on here.
Right, because we're conditioning on not ending up with some pair of things, which makes each of those branches less likely, including the one that we didn't, including the first one that we pulled, including like the first choice we made.
I'm not sure what you mean by including
And
the first choice.
we choose between red, blue, and green, and then
Yeah,
after we choose one of those colors, we choose between triangle, giraffe, bar, soap. And because we're after the fact, we're looking at all of that after the fact. We're conditioning on we didn't get a red bar of soap, so chance of getting red is, in retrospect, less, which is maybe not what we want.
Yeah.
And we'd like to just say we didn't get a bar of soap and not have to worry about the red part.
Yeah. And so this form of UDT is what enables us to do that. Like, because this treats our choice as an independent fact from what happens, right? Like, it can be abstractly true that we, as a function of seeing that Omega asks us for $10, we give up $10, whether or not that scenario happens. There's just an independent mathematical fact of like what we do, or maybe I should call it an independent counterfactual fact. It's a mathematical fact if we're a mathematically defined entity, like if our algorithm is well defined.
If it helps, Norman, I think it can give you. You were asking earlier about the meaning of these two internals, and I think I can give you that if that helps.
Oh, sorry, I don't. I wasn't able to match your what you said with any question. What the meaning of internals?
Of the inside parts of O equals O implies A equals A, and then A of O equals A. So if I've understood it correctly, and please jump in to correct me if I've got this wrong, Abram. That first one, O equals O implies A equals A, is saying if the agent, like we have this agent, and whenever it, and if it sees O, if it sees observation O, then when it does, it takes action A. And the second one, A of O equals A, is just saying in now I wait. I think I've got something tangled up. In right. If it sees O and then does A, and the second one is if it were to see O, it would do A. But we don't necessarily assume that we've also seen O. Does it sound correct, or have I gotten something mixed up here?
Sorry, for me the sound kind of stuttered, so I'm not sure I got exactly what you said. And I'm yeah, go ahead.
That first one is assuming that we see O, and as a result we do A. And the second one is if we were to see O, we would be doing A, but we don't necessarily assume that we see O.
Okay. Yeah. At least that intuitively makes sense. I mean, this conditioning on this statement doesn't imply it's not a subset of O, because we can also just not A, right? So we're not ruling out all the other branches. We're not literally just conditioning on that we see O and we do A. But it is as if we were, because all those other branches, nothing changes, because we can't represent the cross-branch correlations this way.
Yes.
And so we're only looking at this change in expected utility within that arena. So it's as if, like, we'll get the same answer as if we condition on O and also A. in terms of the argmax, that is.
Wait, could someone remind me how then does the second formulation take account of cross-branch
Yeah.
correlations?
So it's because so remember I said this kind of has two deficits. It always and only reduces the probability of O, which is weird. And then it doesn't represent cross-branch correlations because we're only knocking out stuff in that one branch that we're talking about. What this does, by saying that this fact is independently true or false, whether or not we're in that branch, it's just like there is this kind of counterfactual fact. So the branch probability can depend on that fact in an arbitrary way. Like when we condition on this, it can change the probability of observations in any way we specify. And then also the conditional probability of what happens in a branch can also depend on that in some arbitrary way. So that when we condition on a branch and condition on this policy point, then we have some distribution on what happens in that branch that can just depend in any way that we like on this policy point.
Well, I guess my understanding now is that the second formulation enables things in the environment to, like, it's like the quasi-codes you're using, like to the lower quasi-codes, like other agents in the environment could use this as a fact to affect things in other branches. For example, the counterfactual mugging situation.
Yeah. I don't see why the quasi-quotes are relevant exactly, but yeah, it's like as a result of the richness of our representation, other agents can depend on this fact. Yeah.
I do actually sort of wonder about the tie to functional decision theory here, because it seems to be what's going on in the second one.
Yeah. So it has in common with functional decision theory that the algorithm of the agent is considered this like abstract node that can vary and then has some relationship with the concrete physical stuff that happens.
Yeah, and in particular, we're having the action we take on seeing O be whatever it would be best in expectation for it to take on seeing O.
Yep. But the difference, of course, is the functional decision theory is trying to take some causal counterfactual, whereas the this is evidential.
Okay.
Okay, so yeah.
Doesn't have nice coherence properties yet.
Right. So why doesn't this have the nice coherence properties that we want? The thing I'm trying to point to is that here we have the observation participating in a propositional way. Like this can be the Q type expressions that we were talking about in the context of BLI. And then reasoning about this in an appropriate way is just propositional coherence. But here we have the observation participating in like a first order way, where we have some function that it's being passed to that has an output. And so we don't yet have like at least if we do, it's not obvious. It seems like we don't yet have the sort of coherence properties that we need to be able to reason about this sort of situation in a way that will get us what we want.
Would anything catch fire if, on the grounds that we have an equality on that second version, we tried to replace the material implication with the biconditional in that first one? Is that possibly just a solution that's been staring us in the face?
So instead of saying that in the cases where O, it had better be the case that A, we're saying that O if and only if A.
Particularly because of the decomposition into conditional and contrapositive, if we see O, then we do A, and also if we didn't do A, we can't have seen O.
Yeah, okay. I think that it still has the same problems. Like, we're not able to change the probability of stuff that happens in other branches based on that.
Can't we? I mean, there is explicitly mention of other branches right there. If we didn't see A, we can't. If we didn't do A, we can't have seen O.
I'm assuming that you're specializing the actions to observations here, right? So it's like, it's not just we go left if and only if we see O, but
Yeah,
like,
no, that version would not work. It's explicitly the actions you take somehow dependent on some set of observations you get generated from some pool, and the actions you can take limited by that pool,
right.
or
So
like associated to that pool.
yeah, and so then you can't do any cross branch correlations, right? Because you're only like ruling out worlds that are already conditioned on O. They're already O is already true. Because all of the actions are subsets of O.
Not of little O, I mean, they'd be dependent on big O somehow, or like the set of little O's you could. Or I guess I'm thinking of this in an excessively decomposed way. I think I'm thinking of like we have some setup. That setup gives us one of a handful of enumerated O sub I. Each of those we can associate to some A sub I, and then that's the end of that setup. And then there's another setup, and that has its own set of O sub j and A sub j we attach to those. But I don't think that's actually what you're aiming for here.
Yeah, I'm not quite understanding. Should we just move on, or do you want to try?
If I could try one last time, I'm thinking about like the setup is surprise. There's now a deck of cards, and then our observation is something like hearts, diamonds, spades, clubs, and then we have some action we could maybe take on each of those suits, and then we put the deck of cards away, and we pull out a chessboard, and observation on first move is a pawn move, observation on first move is a knight move,
Okay.
observation on they decide to give us a free rook, and then we put the chessboard away, and we, I don't know.
So if you choose, let's say that the actions based on cards are left and right.
Mhm.
And so you're assuming that if you,
I would specifically say at this point it's left sub cards and right sub cards.
right. Yeah. And so if you choose on seeing a diamond to do left sub card, then you cannot take that action with respect to any other cards, right? Because you're taking the if and only if.
Yes, and that's why I'm a little bit less convinced now that that's actually what we want, because you might
Okay.
want to be able to do that, or like you might want to
Right.
at that point require that you reduce to I don't know, some kind of strategic indistinguishability condition where you group things specifically by the action they make you take. But that's maybe backwards.
Yeah, my intuition, I guess, is that everything that's sort of like this is just a terrible hack, and we really need to do something like this.
Okay.
What's the failure mode of like
Of
failure
this?
of coherence? Yeah.
Oh,
Could you give a concrete example?
sorry, you want a failure of this, or you want a failure of the coherence properties here?
The claim that conditioning on that doesn't have nice coherent properties.
Okay, yeah, that's a good question. So, I think that will become clearer as we go forward. Hopefully I'll be able to answer that question in a couple of slides, but I don't have a good answer right now. So the assumptions that we thought about with Martine are like, so we have universal instantiation. I should maybe have put brackets around this part. So like if you have for all x 5x, then any instance of phi for like where c is any constant, you want to like sorry, I should say if you believe this with a certain probability, so you believe the for all with probability 0.5, then you should believe the instances with probability at least 0.5. So you can see how this is something that like logical induction traders would eventually learn to enforce in specific cases, but you would never have it enforced across all sentences small and large at one time. And the proposal here is to enforce this across all sentences small and large at one time. Of course, this starts to get into like first order logic, and we simply cannot enforce all of the rules of first order logic while remaining computable. But the conjecture here is that we're not straying too far from computability. This is like a small enough fragment of first order logic. We're just saying, well, look for these universals that you believe, and you'd better believe the instances. And so the sensibility of this approach hinges on whether we can specify a computable probability distribution that has this property. And then the second idea is hypothetical marginalization. So the idea is that if you have these are like new expressions that I'm introducing to be able to do some work. So this is like a function that like pulls out the value of x in Q. So we're like able to say, well, I can look at this big table of values and I can pull out this x that I'm interested in. And we required that the very first like we require that our prior that we're trying to specify just knows the output values of these functions, so that if it is indeed the case that v of qx equals r, then the probability of that is just 1. So I'm like, we might not need this, the hypothetical marginalization condition, if we have an appropriate notion of real value coherence. So if we if these long descriptions Q are really just conjunctions about claims about real values, conjunctions of claims about real values, then from real value coherence, we just have like, this, we can understand this Q is just like a joint state about a bunch of real valued variables, and we have coherence about reasoning about this sort of thing. And so maybe we don't need the hypothetical marginalization in this case, but this is like the specific case of that I will need for the reasoning that I'm going to sketch. So these are like my current tentative answers to that question of what are the coherence properties that conditioning on this doesn't have. And then I'm going to argue in favor of these properties. I'm going to argue in favor of these two properties being somewhere in the right area by sketching out the sort of work I want to do with them. So, yeah, any questions on those properties?
Mostly just what C is there.
It's just a constant as opposed to a variable. Like fill in some constant here. Like
should that not be like for all phi exists C, or what?
So if we just have the for all,
yeah,
then we should be able to instantiate it, right? So if we have this for all, and then there's a term in our language for the number 3, then we should be able to say phi of 3 as a consequence of this for all.
Oh, okay. I had that grouped wrong. I thought it was for all x, comma, if phi of x, then phi of c for arbitrary phi and c. But no, this is if for all x phi of x, then phi of c.
Yep.
Okay.
And so, yeah, what I'm trying to get is that if the probability of this for all statement is at least some number, then the probability of the application to C is at least that number as well. But if we have propositional coherence, then just having all these material implications is sufficient.
I probably need to leave shortly, by the way.
Okay. So yeah, so I have like my viability sketch, which is applying these principles to try to get the correct answer in counterfactual mugging, to try to show that these principles are what you need in order to reason about updateless decision theory type problems in the correct way. And so, yeah, it's sort of a mess, but it's pretty short. So the viability sketch is like, so we have this counterfactual mugging where we're starting at our P0, and then we have some notion of ask branches, which are the branches where Omega asks for $10. And then we have some notion of the receive branches, where are the branches that we may or may not receive $100 from Omega, depending on what Omega thinks we will do in the ask branches. And so P0 thinks that P10 arbitrarily will satisfy either ask or rec with most of the probability mass, with about equal probability mass each.
Oh no. I know I've been writing this down this whole time, assuming that was P theta.
Oh, sorry.
That's okay.
Yeah, that's just supposed to be a 0.
Okay.
Is it for disambiguating with O?
Yeah, this is terrible, right? Because it's like I use the letter O, so I put a slash through 0, but then that makes it look like theta, or it makes it look like the empty set. Like,
You
or in
make
an
sure the
extreme
slash
case,
is diagonal and contained in the bubble. Then it looks like
Yeah.
then it looks like a 0.
all right.
You need to make it vaguely ovally instead of round, and then put a little diagonal slash that doesn't go outside it.
So anyway,
I think this is a very, very good idea conditioned on the fact that Greek letters don't exist. But they do. Oh,
all right.
oh, Roman is having some difficulties.
Yep.
Yeah, unfortunate. So yeah, so we think either ask or rec will happen in the future. And we furthermore believe these two universal statements. Yep, see you, Roman. Yeah, I might end up reiterating this given that Paul is also having to leave soon. But so let's see. Yeah, we believe these two universal statements with high probability. Namely that for all Q prime, ask of Q prime implies that if we give, like if when omega asks, we give, then we get minus 10 utility. So this is just trying to set up the decision problem, right? And if we refuse, then we get 0 utility. And then for all Q that are receive type, for all Q double prime that are ask type, then if we give in the double prime, so this is like if any of our cells that are
These
asked,
square brackets are wrong.
oh, sorry, I believe you, but I won't try to verify. Okay, so yeah, this is like if all of our cells that are asked oh wait, sorry, yeah.
Abram has frozen in my screen.
I'm
No, just thinking very hard.
I'm just trying to get it clear in my head.
Oh.
I'm like, maybe I am being confused by the wrong square brackets. Sorry, I'm just trying.
I might actually have
basically,
this wrong though.
like the point of this is to just set up the problem, right? I'm just saying like,
No, I was wrong. This is okay. Because
okay,
it needs to be if we're in a for all Q prime, if we're in a receive branch, then first check whether if for all Q double prime, ask on Q double prime results in action on that branch being give. That does need to be all in a pair of brackets. I was a little bit confused about what was going on where.
yeah,
And
okay,
if that's the case, U equals plus 100, close
Right.
that whole chunk, and also the other part is maybe weird though.
If that's not the case, then if any
Oh,
of
then yeah, then 0.
if any of the ones that are asked fail to give, then 0. So this is like a pretty punishing omega.
And I
But
think the negation needs to be inside the bracket there. Because right now it says, and if it's not the case that asking Q double prime results in the action being give. Wait, no, I think that's still okay. Never mind. I think that's still okay. I would have just written it differently.
yeah,
Because I think you can, in fact, just move the negation through the bracket here, which is what I was unclear on.
okay. But yeah, you're convinced this is
Negating the
basically
whole
like,
conditional is the same thing. Yes, sorry about that.
yeah,
I would just
so
write that as
basically,
exists Q double prime not happen.
yeah, I think that makes sense as well. I think that would be less. I mean, it's kind of like clear that we're partitioning into two cases this way, but the exists is maybe clearer to read. So yeah, this is the problem setup. The thing that I didn't write that maybe I should have is that we believe each of these with high probability. And so then the claim is that given my two assumptions here, we will now evaluate this in the correct way.
Mhm.
So long as ask and rec are definable from V and P, then universal, yeah, I haven't written out the proof at all.
Uh-oh.
I'm just claiming this. Yeah, I have written out the proof in some email with Martine like a year ago. But yeah, I should have tried to get that in slides. Maybe next week. So yeah, that's basically the end of my slides. So yeah, to put a cap on it, it's like,
Finally there.
okay, so now if all of that sketchy stuff that I've sketched out works, which like of course we know some of it doesn't quite work, like we have complaints, but if we can like get all of that stuff in ship shape, then we can combine the proofs of tiling for UDT with the modified logical inductors that are Bayesian logical inductors plus universal instantiation plus maybe the like real value coherence, or maybe this other property of like unpacking observations. And then it behaves updatefully with respect to any information that it thinks it should behave respectfully to. So it kind of addresses our concerns of the initial prior being terrible, and it kind of vindicates the long-held idea of updateless decision theory that we can get a UDT that works with some kind of computational uncertainty module. So that's the talk. That's the project.
Great, I'm happy to get started.
I have a question for the big the big thing, like about the need of having to enforce these rules, and specifically for a comment Abram has made a while ago, that if we just assume that first order logic is already implemented like all the things all the logical inductor beliefs are compatible with first order logic, then it would not be computable. So is that what you said?
If
Okay. So
if the wait, so if the logical inductor beliefs are required to be consistent in the first order notion of consistent, rather than only the propositional notion of consistent, then it would be non-computable, because we know that the implication relation for first order logic is not decidable. So we can't, there's no computable function that takes in first order statement A and guaranteed to always halt and always pump out an answer that's yes implies B, for whether A logically implies B.
okay. Yeah, I'm just thinking would importing reflective oracles be a shortcut, because they are they like reflective oracles are what would effectively achieve the marginalization assumption without implying like halting being
So I would say that I wouldn't use reflective oracles here. I would use Paul Christiano's reflective probability theory, which is a very similar thing, but reflective oracles talk about computations only, whereas Paul Christiano's reflective probability distribution is a probability distribution on logic. So we're starting with like what we want here.
I need to
Which,
see ya.
yeah, so yeah.
Bye-bye.
So it's a probability distribution on logic, which has reflective properties that it knows stuff about its own probability distribution. So we can't know everything about our own probability distribution, because we have the liar type sentences we discussed earlier of like the probability of this very sentence is below 1/2, like strictly below 1/2, then there's no probability that we can consistently set that to. Therefore, perfectly knowing your own probability distribution is inconsistent. But we can almost get that. And that's what Paul Christiano discusses in that paper. He called it a probabilistic truth predicate. I think that's the wrong thing to call it. It's a reflective probability distribution. There's no truth predicate there. But yes, that could be a shortcut, in the sense that we can consider updateless decision theory within that setting. And that's something that we could do instead of trying to use logical induction. So that would give us a formally well-grounded setting in which to carry out our updateless decision theory tiling theorems.
Why are you suggesting to replace logical induction altogether? I thought it would be just like on top of it.
I see. So I guess I don't see the point. Like, if if we're doing logical induction, then we are doing something that's computable, right? Like part of the point here is that it's a theory of computational uncertainty, which is itself computable. And so we're in the business of like specifying algorithms that you could actually run, even if maybe it would take a supercomputer bigger than anything that humanity could ever build. At least we're specifying something that can hypothetically be run, and maybe we can get increasingly realistic from there. Whereas reflective oracles and also Paul Christiano's reflective probability distributions are not computable and cannot be run. They can only be approximated. And so it's a different kind of connection to reality. And so if we're giving ourselves that headroom to do things that are not computable, then we might as well go all the way and just use Paul Christiano's self-reflective probability distributions instead of logical induction. And that might be a good thing to do because it might like simplify things and give us a good foundation for developing these tiling proofs without worrying too much about actual computations. But then I would want to, after doing that, I would want to move on to the logical induction version anyway.
What makes you believe that this could actually be achieved without breaking computability? Is it that what we want here is strictly less than what the problem that reflective probabilities or reflective oracles are trying to solve? I don't really get the intuition for this. I don't have the intuition that it's exactly that we're lacking either. I don't have intuition either way. So I want to know.
So I guess my intuition is from like starting with logical induction, which is computable. And then we're making these modifications that I think it's plausible that they don't break computability. So it's like similarly to how the propositional consistency doesn't break computability because for the finite number of small sentences, we can just check. And then for the large sentences, we can just build the probability distribution in this particular way that makes it easy. I mean, it's still computationally hard because propositional consistency is computationally hard, but it's easy to see that we can computably like continue building this distribution up because we're just adding sentences that are like independent. And so we can create this computable probability distribution, which is propositionally consistent and which is like a logical inductor on small sentences. And so then the idea here is similar, that like we just want to modify such a process to enforce universal instantiation as it goes and enforce this hypothetical marginalization as it goes. And just like, well, that shouldn't be too hard.
Mhm. So why are you saying that you you don't like either of these assumptions?
Yeah, okay. So hypothetical marginalization, what I'm saying is that I think that if we can get it to follow from some form of real valued coherence, that's just much nicer, like much better motivated. That
Some form
we're
of,
just
yeah, I don't understand the the thing that you think it could follow from the
okay,
real
yeah,
value.
maybe I have not explained this adequately. So is there a slide actually? I think what happened is that I used to have a slide about this. I ended up removing it in favor of something else. So maybe that's another thing that I should um, try and spell out more in the few sessions that we have left. But
Thanks.
like basically what I mean by real valued coherence is that if you have like a real number A and a real number B, and you have a high probability that A is greater than B, you don't know exactly what these are, but you have a high probability that A is greater than B. And then you similarly have a high probability that B is greater than C, then you should have a high probability that A is greater than C. And this does not follow from propositional coherence, right? This is like an extra, like it seems obvious, but it's an extra coherence property. But I'm not saying that's necessarily sufficient. I haven't figured out enough exactly what real valued coherence would mean. I just have in mind things like that, like just reasoning about real numbers in such a way as to like enforce the property that similarly to how propositional coherence forces that you have a probability distribution, like an actual probability distribution, not just approximately, on the propositional worlds. Similarly, I want to enforce maybe approximately in this case, maybe up to some epsilon. I'm not sure exactly how it goes, but that you have a actual joint probability distribution over all your logically uncertain variables that are these like real valued entities. So that if you have some x that is a real valued thing, then your belief about what x might be is itself a probability distribution. And then if you have some y that's another real valued thing, again, you have a probability distribution over the values that y might take on. And then furthermore, when you consider like the joint values that x and y might take on, you have an actual probability distribution. And this just keeps going as you can join more and more real valued variables that you're reasoning about. You just have some probability distribution, maybe up to some epsilon accuracy. Even as we get into large sentences. And I think this gives us a lot of things that we might want, because these big observations that we've been talking about with Bayesian logical induction are themselves just claims about what a bunch of real valued variables are doing, where the real valued variables are our future beliefs. So maybe even Bayesian logical induction itself follows from some adequately good formulation of, or adequately strong formulation of what real valued coherence is. I'm not sure of that claim, but
No, okay. I think that your way of describing it reminds me strongly of the structural research that I said I've been auditing.
oh,
Yeah, because well, so I'll briefly explain the key idea. It's like they have a notion of structural independence, which is dual to like the independence in probability theory. And the structural independence is basically it's definable on these things called vector space models
okay.
that would be then equivalent to like independence of all random variables that's like for all the random variables that could be defined on this vector space models respecting some of its structure. These random variables would be independent. That would be equivalent to like a structural independence property that's that could be formulated independent of those. No, not this independence. Like yeah, not using those probability distributions at all.
Okay. Are they recording their talks?
Oh, no, like they're not having talks. We're not having talks. Yeah, it's and that this is all prior research.
Yeah.
This
Okay.
is spelled out in the vector space models paper. I will send you that after the meeting.
All right.
But yeah, so you see the connection between this and what you're saying.
I'm not sure.
It's an analogy, not yeah. So it's like what you're saying now is essentially that we have some properties over logic, like what we think logic should behave. But now because our logical inductor deals with logic probabilistically, so these logical coherence coherence means like respecting logical rules basically are affected as probabilistic equations.
Yeah. Okay.
So it's really like the situation where they have some structural feature that's it relates to random variables defined on that structure, and they have like they are able to characterize what's the probabilistic requirements that corresponds to that. Yeah.
Okay. Yeah. It kind of feels to me like we're not necessarily that far off from being able to define something like given a probability distribution, give kind of a semantic unpacking of that probability distribution, like in terms of some formal version of, well, what kind of ideas do you have to have in order to understand this probability distribution? This is also like very connected with the work of Sam Eisenstadt, but he's been working on this thing called condensation, which is, of course, also heavily inspired by this factored spaces stuff, since he worked on that as well with Scott. And Yeah, condensation is kind of an attempt to answer this question of like, okay, given a probability distribution, how can we understand it?
I think this problem is interesting, but yeah, like yeah, I'm not sure to what extent we have to solve it or articulate it in a transparent way in order to build the thing we want to build now.
You mean in terms of this research program that I've been presenting? I feel like there ought to be a connection in the sense that it just ought to be the case that understanding semantically what an AI is doing should help us trust it. And so
and understanding semantically would entail that these semantics be connected to probability distributions.
Yeah, that's what I have in mind. Yeah, like of course what we would ultimately want in this kind of tiling setup is that the successor has exactly our probability distribution so that it can do like update list decision theory with respect to exactly that probability distribution. This is of course a conjecture. I'm not saying I proved something like this, but like I think you can prove things like this in simple settings. So maybe in that extreme case, well, even in that extreme case, understanding would help you verify this, right? Like how do you become confident that it has your beliefs? Well, you should understand what beliefs it has. But maybe in a case where we relax this requirement and we're like, okay, maybe we can't get like exactly the beliefs that we endorse into the AI, partly because we're confused about what we even believe. We have uncertainty over our beliefs, but also for other reasons, then maybe still we can achieve a higher degree of trust with the AI by understanding what it is that the AI believes and seeing that it doesn't appear to have any beliefs that like obviously lead to horrible consequences or something.
Like to formalize a way in which AI beliefs are approximately compatible with ours without being exactly equivalent.
Exactly, yeah.
Yeah, I also have a tangent thought, but okay, just 30 seconds. I a while ago I had the idea of like rather like what you mentioned, like the sentence like we are not able to access probabilities reflexively in an exact way because of like the fundamental limitation of the semantics. Are there some properties that or like some functions of that human values must serve such that it is like in some sense this is what the current state is already almost the best we can do.
That seems doubtful to me. Like, of course, probabilities and utilities are a way of understanding what an agent is doing. And so if we try to make this claim, like, okay, we're uncertain about our own beliefs, but what is that uncertainty about exactly? And we try to make this precise, then it's basically about the intentional stance that we take with respect to ourselves. How are we interpreting ourselves as agents? And so I feel like when I visualize humans trying to get more precise about this, it seems to me that, of course, there's not some objectively correct answer as to how to take something as an agent. So in that sense, there's a lot of room for uncertainty. But I feel like there's a lot of soft constraints that we might endorse, like simplicity in how you interpret something as an agent, but also just like we think that, like when I regard you as an agent, I don't take everything you say as literally an expression of your beliefs, but the goodness of fit of my regard for you as an agent is very, very heavily biased in that direction of taking things that you say as literal expressions of belief.
Okay.
So that's like another constraint, and so I feel like it's plausible to me that if we like kind of put together all these constraints that we might endorse for how we regard humans as agents, then we probably get something that's like pretty constrained, that we can say like fairly precise things about what people believe if we're
Wh-
like
what do you mean? Like these soft constraints are so so it to me it sounds like, because like the first soft constraint, like simplicity, is also effective at like as like outcomes like in the Solomon of prior. So it sounds to me like you have already have a prior hypothesis space over which you apply these soft constraints and single out belief. But where do you get this prior from? Data?
Isn't Salmanov like a better starting point than data?
But
I mean,
we're talking about values and beliefs.
yeah.
I haven't actually formally studied Solomon yet. I plan to do so soon. So I don't know how.
Yeah, I'm not
hard.
claiming that Salmanov is exactly what I want here, but
You mean something of that type signature?
like
Or,
logical induction is of course closer to what I have in mind. But then I like by saying simplicity prior, I'm saying, well, if we were trying to specify a logical inductor that would have beliefs we would actually endorse, then it would be like we would put some more weight on simpler traders, of course. But also, this isn't the only consideration for how much weight we want to put on a trader. It's complicated. I don't know. What I'm trying to say is, like, imagine an ideal, like, judge of character who, if humans could analyze what this judge of character were thinking, we would be like, ah, yes, they're thinking in the right way, but they have much more cognitive capacity than a human does. my claim is that this person looking at humans and like seeing like the whole lifespan of the human walking around and doing things and saying things, and also maybe they get like brain scans, they can do like idealized neuroscience that's better than the neuroscience that humans have done. My claim is that this person would know more about what you believe than you would. That's what I'm claiming. Like this person could reach some firm conclusions about what it is that you believe and what it is that you value that are stronger than conclusions that you're able to reach in your current state, and accurate. That's just my intuition, that like, no, we're not like stuck in this like current state of uncertainty about values. It is possible to do at least somewhat better, even if we have fundamental theorems that we can't have perfect self-reference. Now, of course, it needs to be said that this idealized reasoner, like specifying mathematically what that would even mean to be this good ideal judge of character, talking about these soft constraints and this question of where the prior comes from and all of that, that is itself bound up with the question of what human beliefs and values even are. We can't separately figure out what the ideal judge of character is and then use that to figure out human beliefs and values, because human beliefs about what constitutes good scientific reasoning go into specifying this good judge of character in the first place. So if we were to actually try and build this good judge of character, which is the value learning problem, then I see it as being like a kind of recursive improvement process of like starting with the understanding that we have and then kind of trying to bootstrap from there. And maybe there are like fundamental limits to that sort of bootstrapping process over and above the fundamental limits of reflection that that we're talking about, that would keep us from getting to some kind of ideal judge of character that can pin down your utility function really well. I don't currently see why that should be the case, because although this process is somewhat loopy, I don't think it's that loopy. Like, in order to do that good neuroscience, to study what's happening in the brain, we just need to specify things about what good science is. And facts about what good science looks like seem like relatively independent from like ethical considerations that go into specifying a utility function, for example. So it seems to me like in some sense we have like all these different sources of information that can flow in and like constrain the problem.
Yeah, interesting. Like the way you frame it sounds, it sounds like a plausible path for clarifying values in principle. But now I'm wondering, like, why are we? It seems to me that we haven't really gotten far using this path of idealization in like so like we've already gotten pretty far in terms of technology and math, in my view. But if what you said is like actually works, then shouldn't we be able to already specify human values much better using these advances now? Or do you think like there's like some actual factor like boostable by AI in this loop or process that's
I see. Yeah, interesting.
yeah, happy to talk about this with you later. It's
All right.
a bit late for me. Yeah.
All right. Yeah, I should go too.
See,
All right. Take care.
see you. Yeah, take care.